In this video, you're going to learn everything you need to know about Java generics, so by the end of this video, you'll be able to write Java code with confidence. Hi, I'm Mosh Hamedani, and I've taught millions of people how to code through this channel and my online school, com.codewithmosh.com. This video is part of my ultimate Java mastery course, so once you finish this video, if you want to learn more, you may want to look at the complete course. Now let's jump in and get started. Before we talk about what generics are, let's look at the problem they try to solve. So in this project, I'm going to add a new package called generics. I'm going to write all the code for this section inside this package. Now let's say we want to implement a class for storing a list of integers. So in this package, we add a new class called list. In this class, we need an array to store our integers. So let's declare a private field, private integer array items, and we set it to a new int array of 10. Now, we shouldn't hard code the length of this array here. It's better to add a constructor and receive the initial capacity of this array as a parameter. But let's not worry about this and instead implement a basic list class. So what is the next thing we need here? We need a method for adding a new integer to this list. So a public method, public void add, which gets an integer called item. Now here we also need a private field for keeping track of the number of items in this list. So private int count. Now back to our add method, we type items of count, and we set this to this new item. So initially count is 0, and we store this item at index 0. Now here we should increment count, so next time we add an item, it will be stored at index 1. Okay. Now we also need a method for getting an integer by its index. So public integer get, we give it an index, and here we return items of index. Now here we're not validating this index parameter. We're not checking to see if it's negative or greater than the number of items in this list. Let's not worry about these details and focus on an absolute basic implementation of a list. So now that we have a list, let's go back to our main class. Here we create a new list. We want to import the one that is declared in this package that we just created because we have another class by the same name in Java. It's declared in java.util package. We don't want that one. So let's import our own class. All right. Now we call the add method and insert an item in this list. Now let's say tomorrow we want to have a list of users. So first I'm going to add a new class in this package called user. Now in this class, we could have fields like username, password, email, and so on. For now, let's not worry about this. Instead, we want to have a list of users. Here's the problem. This list that we have here, we cannot use this class for storing users. We can only store integers in this class. So with this approach, we'll have to create another class called userList. And in this class, we're going to have a user array. So private user array. Let's import this type. We call it items and set it to new user array of 10. Similarly, we need a count field, so private integer count. Then we'll have to implement our add and get methods. That's a lot of code duplication. What if in the future we want to have a list of strings? So this approach is very tedious and not scalable. In the next video, I'm going to show you one way to solve this problem. One way to solve the problem in the last video is to use an array of objects here, because the object class is the base or the parent of all reference types in Java. Remember reference types? We talked about them in the first part of this series. To refresh your memory, we have two categories of types in Java: primitive types and reference types. Primitive types are numbers, characters, and booleans. Everything else is a reference type. So if we use an array of objects here, we can store anything in this array. For example, we can store user objects because the user class extends the object class. So let's replace all these integers with the object class. So here we have an object array, and here as well. The parameter of the add method should be an object. And also the return type of the get method should be an object. Now, back to our main class, we can store numbers in this array. We can also store strings. We can also store user objects. So that's great, isn't it? Not really. This is a very bad solution for a couple of reasons. But before we talk about these reasons, I got a question for you. Earlier, I told you that the object class is the parent of all reference types, so we can store any objects in this list. However, this integer here, this is a primitive value. It's not an object. It's not a reference type. So how can we store it here? Well, when we compile this code, the Java compiler will convert this code to something like this. Integer dot value of 1. So we have this integer class in Java. It's a reference type. It derives from the object class. And this class has a static method, value of, which returns a new instance of the integer class. So this is the reason why we can pass a primitive value to this method. By the same token, we have a wrapper class for every primitive type in Java. We have float, we have double, boolean, character, and so on. Okay, so let's revert this back. What are the problems with this implementation? Well, the first problem is that if you want to get the first item in this list, we call the get method. Now, we know that this is an integer, so we may hope to store it in an integer variable called number. But we have a compilation error because this get method returns an object, but we expect an integer. So here we have to explicitly cast the result to an integer. And this makes our code a little bit verbose and noisy. The second problem is that if we use the wrong type here, we'll get an invalid cast exception. For example, let's change 0 to 1. We know that the second item in this list is a string. What if we accidentally try to cast it to an integer? We run our program. We get a class cast exception. Now, the problem here is that we will not be aware of bugs like this until we run our application and test all the functions. So we can only identify these problems at runtime. It would be great if we could catch these problems at compile time. And that's what generics are for. In the next video, I will show you how generic classes help us solve these problems. Let's see how generics prevent the problems we discussed earlier. So let's add a new class in this package. We call this GenericList to differentiate from the other list implementation. Now, we want this class to be generic so we can reuse it to store different types of objects. So right after the name of the class, we type these angle brackets, and inside these brackets, we type a capital T, as in short for type or template. Now, we could use any letters here. It doesn't have to be a T, but T is a common convention. Another convention is E, as in short for element. We use that when we want to implement a class that acts as a collection, so it can store many elements. So here we could use either E or T. I'm going to go with T. Now, this T is a type parameter for this class. So just like our methods can have parameters, our classes can have parameters as well. This T over here represents the type of objects we want to store in this list. When we create an instance of this class, we'll have to specify an argument or a value for this parameter. For example, back in our main class, let me delete all this code. If you want to create an instance of our generic list, we type new generic list. Now here we specify the type of objects we want to store in this list. For example, user, or string, or integer, okay? So back to our generic list implementation, this T represents the type of objects we want to store here. Now we need an array of type T. So private T array, we call it items, and set it to new T array of 10. Now here we have a compilation error because the Java compiler doesn't know the type of T at this stage. Is it the character class or the string class or the user class? It doesn't know what it is. That is why it cannot instantiate it. Now, one simple workaround is to use new object array here, and then cast the result to T array. Okay? Now, just like before, we need a field for keeping track of the number of items in this list. So private int count. Next, we implement our add method. So public void add. Now, instead of an integer or an object, we pass T. The type of T will be determined later when we create an instance of this class. So we call it item just like before. And here we store item in our array. So items of count plus plus equals item. Finally, we need our get method. So public t get integer index. Again, instead of an integer or an object, we return t. Okay. So here we return items of index. Now, back to our main class. When we create a generic list of integer and call the add method, look, the type of this parameter becomes integer. So if I call this method and pass a string, I get a compile time error. This is the benefit of generics. This generic class ensures that every object in this list is an integer. Okay? Now, actually, let's store this in a variable called list. And here we call list.add. Let's pass an integer. Now here's the second benefit. When we call the get method, look, we get an integer. So if we get the first item, we can simply store it in an integer. And here we don't need an explicit cast. If we had a generic list of users, we could add a user object here. And when reading the first item, we would store it in a user object. Okay, again, we don't need an explicit cast. So our code becomes cleaner and we get compile time type safety. So we can catch our mistakes at compile time rather than at runtime. That is the beauty of generics. Now, over the next few videos, we're going to study generics in more detail. You're going to understand how exactly generics work under the hood. So I will see you in the next video. When creating an instance of a generic type, we can only use a reference type as a generic type argument. Let me show you what I mean. So I'm going to create a generic list of user. We can pass the user class as a generic type argument because this class is a reference type. We can also use the object class or the string class. These are all reference types in Java. But here we cannot pass the primitive integer type or short or boolean or float. These are all primitive types. If you want to store these primitive values inside a generic list, we have to use the wrapper class. So every primitive type in Java has a wrapper class. Let me show you. So for the primitive int, we have the integer class. For the float, we have the float class. For the boolean, we have the boolean class, and so on. So this boolean class is a reference type that stores a boolean value. So if you want to create a generic list of integers, we have to write code like this. New generic list of integer. Now let's store this object in a variable of type generic list of integer. Call it numbers. Now, look over here. This integer is grayed out because it's unnecessary. We're duplicating our code. So let's remove that. That's better. Now look at the signature of the add method. It takes an instance of the integer class, but we can pass a primitive integer like 1, and the Java compiler will automatically wrap this value inside an instance of the integer class. So it's going to create an instance of the integer class to store this value. This process is called boxing. So the Java compiler is going to put this primitive value inside a box. Now, when we call the get method, look at the return type. We get an instance of the integer class. So let's get the first item and store it in a primitive int called number. Now, in this case, the Java compiler is going to extract the value that is stored in that integer object. This is called unboxing. So this is how we can create generic types that work with primitive values. There are times you want to add a constraint or a restriction on a type parameter. For example, let's say we only want to store numbers in this list. Perhaps this list is going to support some operations that only make sense for numbers. To do that, here we type extends number. Now, T can only be the number class or any of its child classes. But what is this number class? Well, if you search for Java number class, here you can find the documentation for this class. Let's look at the documentation for Java Platform Standard Edition version 8. So Here you can see that the number class is declared in java.lang package, and it's the base class for these classes like byte, double, float, integer, long, and so on. So all these wrapper classes around numeric primitive types derive from the number class. So with this constraint, if we create a new list of string, we get a compilation error because this string is not a number. So here we can only pass the number class or any class that derives from the number, like integer or float or short. Also, this constraint doesn't have to be a class. It can also be an interface. For example, in Java, we have a popular interface called comparable. We use this interface for implementing classes that can be compared with each other. For example, if we implement this interface in our user class, we can compare two user objects based on some criteria, like their last login date. Then we can sort all users based on their last login date. We'll look at the comparable interface later in this section, but let's see how applying this constraint works. So now we're saying that this list can only store objects that are comparable. So back in the main class, we can pass short here because short values are comparable. We can also pass integer or string, but we cannot pass user because our user class does not implement the comparable interface. Now, if we go to our user class and type implement comparable, now don't worry about this compilation error. We'll come back and fix this later. But we're saying that the user class implements the comparable interface. Now, you can see that the error is gone in the main method. Also, here we can add multiple interfaces as constraints. For example, we can type and clonable. This is another popular interface in Java. If you want to be able to clone or copy a class, we should implement this interface in that class. Now we are saying that this generic list can only store objects that are comparable and clonable. And by the way, note that here we have a single ampersand, so this is not the logical AND operator, okay? Now, back in the main class, we cannot pass the user class here anymore because this class only implements the comparable interface. We can only pass classes that implement both the comparable and clonable interfaces. So this is all about applying constraints. Now, with this constraint, we say that we have a bounded type parameter. This type parameter, this T, is bounded. It's restricted. Thank you so much for watching this video. As I said, this video is part of my Ultimate Java Mastery course that teaches you everything you need to know about Java from the basics to more advanced concepts. So if you want to learn more, I highly encourage you to take the full course. It's much faster than jumping from one tutorial to another. If you're interested, the link is below this video. Thank you and have a great day.